So hello everyone, let's continue our course. Let's continue the lectures that yesterday we are going on. So yesterday we are talking about periodic table, and in periodic table we get to know what are the types of the elements. Okay, we get to know which are transition metals, we get to know which are noble gases, we get to know which are representative elements, and we get to know what are inner transition elements. These kind of things we got. Okay, so now today, from today we get to know one more classification of elements, that is on the basis of it is classification of elements on the basis of metals, non-metals and metalloids. These are the three classifications that are there. Okay, so metals, non-metals and metalloids. First of all, before knowing other things, let us see where they exist in all the periodic table. So you know, usually metals exist on the left side, but it is not the complete truth. Actually 78% of the periodic table is already metal. Okay, that means on the left side, in the middle and slightly even on the right side also, what happens is metals exist. Okay, whoever is more left, that is more metallic. More left means whoever exists more left is more metallic. Apart from that, what we can write is whoever is lower, on the lower side, is also more metallic than upper one. So if we compare, what we can say, moving from left to right, metallic character decreases. That means on left more metals are there, on as we move right, metallic character slightly decreases. As we go from up to down, what happens is on the upper side there is less metallic things. If we go down side, more metallic things are there. This is the thing. Okay, now let us move to non-metals. Non-metals. So what happens to non-metals is, so they exist on right side of periodic table, on right side or right hand side of periodic table. This is the thing. Okay, apart from that, what we have to know, similar to metals, you can write the same thing, more right, that means more non-metal or more non-metallic character, more non-metallic character. Similar to that, if you talk about from up and down, upside more metallic character, downside less non-metallic character, less non-metallic character. So this is all about non-metals, metals and their existence in the periodic table. Okay, we get to know where they are existing. Apart from that, what is happening to them. Till here, if anybody has to ask something. Okay. Middle also same. In middle also what I told you, in middle also metals exist. 78% of them are metal only. So in middle also metal. Which group? We cannot say exactly which group. Noble gases, as the name suggests, gas is not a metal. Gases are obviously non-metals. Metals are cations, not metals are not cations. Metals form cations, to be more precise. Noble gases, obviously, they are non-metals because they are on the rightmost. Percentage of non-metals you can calculate. Just now I will show you the diagram. There you can calculate very easily. Why do some elements show variable valencies? Variable valencies, it is because of some reasons that you will get to know. Wait for the D block. Okay, in the D block you will get to know. There precisely we will understand that which variable valencies are there and why they are showing them. We see gradation in physical properties as mass increase, but why electronegativity decrease as mass increase? So you will get to know this also when periodicity is discussed. As mass increases, what happens is the hold of nucleus on electron decreases. So if it can't hold its own electron, how it can attract the shared pair? And electronegativity is all about sharing, attraction of shared pair of electrons. That's why. Good evening, Ritika Kaushik ji. Metalloids. Yeah, metalloids are coming. Metals where in periodic table? Everywhere, mostly everywhere, like on the left side and in the middle side all, and slightly on the right side also. Okay, Gautam Ritesh, good evening. Okay, let's move. Let's move to the next one. Metalloids. What about metalloids? So metalloids are those things which show in between properties of metals and non-metals. They show in between properties. Some properties like metal and some properties like non-metal. In between properties of metals and non-metals. Now where they exist? So that is also very easy. They exist at the junction of metals and non-metals. That means wherever metals are meeting non-metals, there some of the metalloids are existing. Okay, usually they are 6-7 only. Okay, not too much. They are not in a high number. They are usually very less in number. Okay, that's it. This is all about metalloids and their positions. You will get to know their properties. Wait for that. Apart from that, what I told you, their properties lie between metals and non-metals, and we cannot say about how metalloid character change, because metalloid character is not defined properly. Metallic character can be defined, you will get to know what it is. Okay, non-metallic character can be defined properly, but metalloid character do not have any perfect definition. That's why we cannot find its order also. Okay, so this is all about metals, non-metals and metalloids, basic definitions. Okay, so after that, see this kind of thing. In here, this pink color represents all the metals. If you see, most of the color is pink only. See, this pink color shows us metals. Okay, apart from that, this blue color shows us non-metals, and this green color shows us metalloids. And one more thing, this polonium, this is also green. Consider it as green only. It is also a metalloid. Polonium is also green. So now those who are asking percentage, please calculate the percentage. You get to know 118 elements are there. Out of these, how much? 78% is metal. 1, 2, 3, 4, 5, 6, 7 are metalloids, and other these are non-metals. And one more thing, see here, this is also non-metal. Let me write it by different. See, hydrogen also blue color means it is also a non-metal, even after it is existing between all other metals. These all other are metals. Okay, that's it. I think that is very, very easy. So in this, anybody has any kind of doubt, you can ask. What about the noble gases? See noble gases, here they are, noble gases, here they are also non-metals, obviously non-metals. Gases are not metals, they are non-metals. Can hydrogen be kept in metalloids, sir? No, not at all. How can an 18th group element be a metal? Og. This Og is what actually, this is a synthetic kind of element, okay, and this behaves as metal. This is not gaseous, this behaves as metal. Lanthanides and actinides, you can see lanthanoids, actinoids, which color? Pink color means metals. As you have seen here, pink color means metals. Is francium still exist? Obviously. Francium still exist. Which is greatest metal and non-metal? In what terms you want greatest? Like hero of metals? Where should we use the metalloids? You will get to know. Wait. In all your computers, laptops, in this digital board also metalloid, silicon is there. Chips are made up of silicon. They are also radioactive. Yeah, radioactive metals are there. See uranium. Why, sir, it will melt with respect to time? What? Kaushal, what will melt? Why can't we keep H in metalloids, sir? It shows both metallic and non-metallic properties. No, not like that. We can't keep. You will get to know. It won't show any of the proper metallic characteristics except one. Cesium will react with water. Obviously, cesium will react with water. Why francium will melt with respect to time? It is not called melting, it is called decay. It is a radioactive process, you will get to know. 117 and 118, Google can say anything. Don't believe Google always. And one more thing, don't believe 117 and 118 also always, because they are just lab prepared things and we do not have so much amount of them to be so that their research can be carried out properly. After 110 or even after 100, you should stay away from making any statement about them, because there are no so much research about that. Okay, I think now we can move to some more things, that is properties of properties of metals, non-metals and metalloids. So first we will write properties of metals. What are the properties of metal? What behaves makes someone metal? Okay, let us think about properties of metal. First of all, they are usually solid at room temperature. At room temperature. There is only one exception in this, and you know exception. One guy is there who is metal and still not solid at room temperature, and that is mercury, Hg. Okay, that's it. Exception mercury. Okay, very good. Some of you have written already. Rajesh Yadav, very good. Mercury, Sanjana, very good. Okay, now let us move. What are the other properties? They are malleable, that means can be converted into sheets or hammered into, converted into sheets. Sheets can be formed out of metals. They are ductile. Ductile means wires can be drawn out of them. Wires can be drawn out of them. Now nobody will tell you that I have the wire of hydrogen. Wires can only be drawn out of metals. You can see iron wire, you can see copper wire, you can see aluminium wire, you can see gold wire, you can see silver wire. But the thing is, you will not see neon wire. You will never see hydrogen wire. You will never see helium wire. That kind of things you will never see. Okay, that's it. Apart from that, they are sonorous. Sonorous means make ringing sound when hit. Make ringing sound when hit. When you hit them, they will make ringing sound. This is known as sonorous. One more thing, they have high melting and boiling points. High melting and boiling points. That means they will melt very hardly at very high temperature, and they will boil also at very high temperature. Let me tell you what is the difference between melting and boiling. If solid is converting into liquid, it is melting. Solid converting to liquid is melting. And liquid converting to gas is known as boiling. Or precise definitions are, when solid and liquid are at equilibrium, it is called melting. When liquid and gas are at equilibrium, it is known as boiling. So this is melting and boiling. Metals have high melting and high boiling point. That's it. Apart from that, one more thing, they are good conductors of heat and electricity. Obviously, they are good conductors of heat and electricity. Usually you see electricity wires are made up of metals. Aluminium wire, copper wire, okay, these kind of things are there. Iron wires are also there. Apart from that, silver wire, gold wire are also possible. They are also conducting, okay. They can also conduct electricity. These are all the properties, or these are useful properties of metals. If anybody has any kind of doubt, you can ask. Release H2 gas when react with acids. Yeah, that is also correct. Aishwarya, very good. That is also correct. They have valency of 1, 2, 3, 4. This you should not make statement for now. Lakshmi Anusha. Graphite is poor conductor of electricity. Graphite is not a metal. We are talking about metals only for now. Chemical properties. Chemical properties is not that much small that we can discuss in one class. For chemical properties, we have to take each at least group and then discuss for 2-3 class. Lustrous, yeah, lustrous also you can write. Yeah, one more point. Lustrous also you can write. Lustrous means shining appearance. Lustrous also you can write. Okay, so shining appearance. Apart from that, Hg also shows these properties. Yeah, Hg also shows these properties, most of them. Release CO2 gas when reacted with carbonate. Okay, these are all chemical properties. High density we can say, obviously. High density, yeah, that is also correct. Metals having reacts with water, please correct your English. Positive charge, wait for that, that is coming. What about gallium and cesium, sir, of high melting point? Yeah, their melting point is not so high, but that is also okay. Because we are talking about general trends, there are some exceptions always. High density, no brittle, no. Strong means no brittle only. Now let us move to one more most important property, and that I am writing with, let us say, this color. This is very important property. Make star on it. That is one of the most important property. So metals lose electron during chemical reactions. This is the most important. During chemical reactions, metals always lose electrons, or we can basically say that those who are losing electrons are mostly metals only. So usually what metals do during a chemical reaction, during the course of a chemical reaction, what do? They lose electrons. That is the most important point out of metals, and rest you can write by your own, whatever you know, okay, whatever you have learned in your younger classes, high density and all these kind of things, okay, and that's it. And non-brittle, and they are strong, and all of them, these points you can write, okay, but the most important point is this one. Always remember, this is the point which will work for you always. And if we talk about the reactions, then reactions are talked about or discussed about with each group. With each separate group we will discuss them separately, okay. So for now we are not discussing chemical properties, how they will react with what element or what compound. So that we will see in their specific chapters. There are specific chapters for all of the groups. So that's it. Now we will move to next, that is properties of non-metals. Properties of non-metals. Just you have to see the properties of metals and write opposite of that. First of all, they exist on the right side, you have seen, see, okay, what it is written, they are usually solid, so they are gases or solids at room temperature, but they are not strong solids, they are very weak solids. They can become powder very easily. If you put them in your hand and try a little bit force, they will become powder, most of them at room temperature. There is one exception in this, and that is very, very important, and this exception is, always remember, this is only one in the periodic table. Exception is bromine, and bromine is a liquid at room temperature. Bromine is a liquid at room temperature. RT means room temperature. Okay, so this is the thing. Apart from that, they are non-malleable and non-ductile. They are not malleable and not even ductile. Okay. Apart from that, they are brittle, they are not very strong. Apart from that, they are, what we say, low melting and boiling point. Low melting and boiling point. If you see some more, they are not good conductors of heat and electricity. There is also one exception in this. Okay, carbon in the form of graphite. This is, despite being a non-metal, it is very good conductor of electricity. Very good conductor of electricity. Okay. Apart from that, they are usually dull, that means non-lustrous. Non-lustrous. Apart from that, what we can say about, they are non-sonorous. Okay, these are the properties. Okay, so if anybody has any kind of doubt, you can ask till here, or somebody who knows some more properties, please suggest in the comment box. Sir, bromine cannot be solid according to 10th. Everything can be solid. Just give temperature. Temperature is important. Iodine is solid at room temperature. Iodine, you can't say that lustrous, but it is a yellowish kind of, means yellowish kind of solid. Carbon in the form of diamond is a little bit lustrous. Non-metals gain electrons. Yeah, that is very important thing that we will write in the last. That is the last important point. Why aluminium is used in making utensils? Obviously, it is having very high conductivity of heat. High conductivity of heat. Exist in all states. Obviously, you can see solid, liquid and gas, all three are there. This is the normal thing that you can understand. Diamond is exception for low melting point and non-lustrous. Obviously, you know this. Diamond is very high melting point. Low density, yeah, you can write. Good evening. Transparent, not at all. Not at all, you can say transparent. Fluorine is highest electronegativity element. This is the part of periodicity. means when periodicity is discussed. Is zirconium a metal or non-metal? See, find your zirconium, you will get to know. If you see it is 40, it is a transition metal. What meaning lustrous? Lustrous means shining. Shiny surface is known as lustrous. Okay, let us move. Now let me tell you again the most important point about non-metals, and that is what? That these gain electrons during chemical reactions. During chemical reactions, what will happen? That non-metals are usually found gaining electrons. That's what is all about the properties of non-metals. See, this is all about properties of non-metals. Now let us move. Now let us write the next thing, that is properties of metalloids. Properties of metalloids. So their properties lie in between of metals and non-metals, metals and non-metals. Okay, apart from that, they are also some that moderate density kind of thing, moderate melting and boiling point. Okay, so all this melting point, boiling point, and what do you say, density, all of these lies in between of metal and non-metal, between metals and non-metals. That's it. Okay, between metals and non-metals they lie. Now let us think about, they are also usually non-malleable and non-ductile. Non-malleable and non-ductile kind of things, non-sonorous. They are also moderately brittle. They are also brittle kind of things. These are not so much important points. Okay, these are all moderate points or in between of metals and non-metals that you can write by your own. The important thing is, some of them act as semiconductor. Not all of them, but some of them acts as semiconductors. Act as semiconductors. And remember what I said, not all, some of them. Some of them acts as semiconductor. Now this semiconductor is a very important thing. What we have to know about this is, they are insulators or non-conductors of electricity at room temperature, but they become conductors at high temperature. So as soon as temperature become high, what happens? They change from insulators to conductors. They start conducting electricity, and that is a very important thing. One more thing, their current supply is so slow and so less and so controlled that these kind of things are used in microchips. And you know what is microchip? Microchips are all about computers, processors, CPUs, everything that is digital is made up of somehow microchips only. That's why these are very, very important things. Okay, one more important thing that is on the basis of chemistry, and that is what? That they can both lose and gain electrons. Both lose and gain electrons during chemical reactions. During chemical reaction. So this is all about the properties of metalloids. Till here, if anybody want to ask something, you can ask. Colored ions are formed, that is for transition elements. Solid state, yeah, they are also usually solid. Brittle solids, brittle means solids only, okay. Brittle solids, they are brittle itself means they are solids. Can you show an example of metalloids in chemical reaction? Chemical reactions we will discuss by group by group. There is a whole chapter for that. Sir, which element is rarest? Some of them are this much rare that they can't even be found in Earth's crust. They are only made in lab. All above 100 are that kind of things. Intermediate conductors, we don't call them intermediate conductors, we call them semiconductors. Si is a semiconductor, obviously. Your name, my name is Prashant. I think I've already told. Francium is a metal.
Anions are negatively charged like Cl. This positive charge indicates that this atom has extra positive.
Okay. So these are the things that we have known till now. So hydrogen is a non-metal. These all things from here to here and all these also. See, this much is metals. This much of the things are metals. Okay. Apart from that, if you see this blue things, these are non-metals. And if you see it properly, you will get to know that these green things are metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium and polonium. So how many they are? 2, 2, 4, 2, 6 and 1, 7. These are the 7 metalloids. 7 metalloids are there, and try to know about them. That is very, very important. If you know, this is very, very important. META. Metalloids. 7 metalloids they are. Okay. Seven metalloids they are, and rest you can see they are non-metals. Okay. Now let us move to one more thing. Okay, let us move to next, I think next topic, that is nomenclature of elements with atomic number, that is called Z, greater than 100. So nomenclature of elements having atomic number greater than 100. Let us think about what were the older ways and how they were changed and why they need to be changed. Okay. Now let us write. First of all, in the older times, whoever is the discoverer of the element, discoverer of the element gives name to it. Like whoever discovers the element gives name to it. He can name it on himself on his let us say some ideal of him, some family member of him, or whatever he want. Okay, whatever he like. He can also name him on the basis of his favorite anime character also. Some of you, if find, they will name it like that. So in older times what used to happen is discoverer of the element give name to it, whatever be the name. Okay, but why this system needed to be changed, why it was changed? Okay, so what happens is there was one element having Z is equal to 104, that means atomic number 104. The American scientist called it Rutherfordium. Rutherfordium. But there were also Soviet scientists, this is called by USA scientists, and Soviet scientists, that is Russian scientists, they called it Kurchatovium. Kurchatovium. Even if today also you see some periodic table that is printed in Russia, you will find out that 104 is written as Kurchatovium. It is not written like Rutherfordium. In the normal system or in the other world systems, usually like whoever are supporters of USA or wherever USA has influence, and in these kinds of areas, this 104 is written as Rutherfordium. But those which are supported by Russia, this is written as Kurchatovium. So there was a dispute. There was a dispute between two countries, America and Russia, about this, that what should be the name of this 104. Then what happened, that all chemistry is judged by, there is a council that is known as IUPAC, that is International Union for Pure and Applied Chemistry. This is a group of scientists that is responsible for naming and sign conventions in chemistry. Their job is to define the naming and sign convention and what are the standards in chemistry. So they have find out a way, they have find out a method of nomenclature for elements with Z greater than 100, means Z greater than 100. They have found a method, or they have found a process. Okay, do you got the history? Why? What was the reason? Till here, I think there is no doubt. Okay, so this was the system, and I think that's it. So this was what we have to find out to bring the names of Z greater than 100. There was some method that has to be find out. What was that method? That we will understand in tomorrow's class. I think that's enough for today. So till here, if you have some doubt, then you can ask. If there is no doubt, then you can leave. That's it for today. Bye for today, and that's it for today. That is the end of the class. Thank you, everyone.